This is the screen recording for my Udacity's Capstone project on the NanoDegree program for Azure machine learning. For this project, I picked a credit card fraud prediction model. The data is from Kaggle, and then the task is to predict whether the credit card transaction is fraud versus non-fraud. So this problem is very important because it seems like every year the credit card fraud transaction has been going up, and there's like billions of dollars of loss with banks. You can see from the data that 270,000 Americans are reporting fraud transactions in 2019, and this number is always growing, right? So if we go in the data set, let's look at the data set, the credit card data set. This is the one that I uploaded. You can explore it. The dataset contains the transactions made from the European customers in September 2013. For the privacy reasons, these column names are hidden, and this is all the columns being already transformed by PCA. So there's like V1 to V28, 28 of them, and there's additional columns time and amount of transaction. You can look at here. The output variable for us will be class, 1 being fraud and 0 being non-fraud. So for the AutoML configuration, this is a classification tags. So the output level is class, and I picked k-fold cross validation with k being 5. And the important thing here to mention would be the accuracy metric. Instead of picking the regular accuracy metric, I picked AUC weighted because there's a heavy imbalance in the data set, and AUC weighted performs better because it assigns when it calculates the TPR and FPR, assigns based on the weights. So let's look at our AutoML model. So should be the latest one I ran was this guy, yeah. And the model is voting ensemble with the highest 0.98 accuracy, and there's, you can click on the explanation to view the explanations, And for the hyperdrive method, I pick logistic regression, and I pick random sampling for parameter sampling, and then I did pick bandit policy for the stopping criteria. For the two hyperparameters, I picked C value as a inverse of regularization strength. So at the higher the value, lower will be a penalty applied. And the max iteration means how many iterations you want to run your model before it converges. So for the hyperdrive, let's go to our latest model, which is this guy. And then yeah, the accuracy in the hyperdrive was a little higher, but for the deployment, I choose to deploy the AutoML method for two main reasons. One was the logistic regression makes some strong assumptions that there's always a linear relationships among the variables, which is not always true. And then the logistic regression sometimes makes simpler assumptions, so there will be higher bias. If we like, it's some things that we studied in our like the class as well, that you want to pick the model with low bias and low variance. And voting ensemble is a combination of weak learners and ensembling algorithms performs better, so on on-scene data. So I picked AutoML model to deploy. And then for the deployment, yes, the endpoints here, if you can look, this is the endpoint created with a REST endpoint, REST UI. The keys enabled, application insights is enabled to true, So, and then there's an endpoint.py file that actually scores the model. So let's try that in our here. So I already have it in. So I run the Python endpoint.py file, and it should respond me with there's two data set created from the test sample, so being passed to run for the result, right? So as you will see, that first data set being passed comes as a fraud, and the second is a non-fraud. So that's pretty much it for the to experiment being ran, and I learned a lot from this class. Thank you everyone and all the participants in the program